Okay, so on to the next little bit with solving simultaneous equations. The question is the exact same. We're still being asked to solve the following pairs. So we want to identify what the value of each algebraic term is. But there's one little difference. And when we look at our two equations, we can see here that for each coefficient part, we do not have a matching number. So we can't just simply add or subtract to immediately cancel out one of our terms. We're going to have to do one little step first. So I'm still going to label this my equation 1 and my equation 2. And typically, a lot of times, it's just easier to look at that middle term. And so here I've got a 4x and a minus x. Now I want these to have the same number. And the easiest way to do that is if I take this bottom equation, if I multiply this whole thing here by 4, then that means this minus x, when I times that by 4, is going to become minus 4x. And then that can cancel out quite nicely with that positive 4x. So that's what I'm going to do. I'm going to take equation 2 and I'm going to multiply it by 4. And when I do that multiplication, I need to multiply every single term in that equation by 4. So 3y times 4 is going to give me 12y. Then minus x times 4 is going to give me minus 4x. And then 5 times 4 is 20. So that's now my equation 3. So I can see here now, in my equation 1, I've got that plus 4x. In my equation 3, I've got that minus 4x. And because these signs are different, that means I can add those two equations together. So I'm doing equation 1, add equation 3. So I'm just going to rewrite what equation 1 is underneath here. Then I'm going to add them up. So 12y add 5y, that's going to give me 17y. The x's are going to cancel each other out. Then 20 add 14 gives me 34. Then solving to find y, so I divide by 17 on both sides. And so I've got y equals 2. Then I want to do my substitution. So I've got to substitute y equals 2 into, and I can choose equation 1, 2, and I can even choose my equation 3 there, but generally the 1 and the 2s, those ones are going to be a little bit easier to work with, so just focus on subbing into one of them. And I am going to choose equation 1 because it doesn't involve any negatives. So I'm just going to rewrite what equation 1 is again. And begin my substitution. So it's going to be 10 plus 4x equals 14. Take away 10 on both sides. That's now 4x equals 4. Divide by 4 on both sides. So x equals 1. And again, just reiterating that final answer, we found y equals 2 and x equals 1. Okay, so let's take a look at question 2. So same idea, I've got my 1 and my 2. And so looking here, I've got this plus 5 and that minus y. So the easiest way to make the numbers stay the same is if I multiply this second equation here by 5. So I'm going to take equation 2 and I'm timesing it by 5. So that's going to be 20x minus 5y equals 10. So that's my equation 3. And then I've got this plus 5y, I've got that minus 5y. So that means I can just add those two equations together for it to cancel. So when I do that, I'm going to have 20x add 3x, that's going to give me 23x. And then 10 add 13 is also going to give me 23. Divide by 23 on both sides. That means x equals 1. And I'm going to substitute that value in, so sub x equals 1 into, and I'm going to choose equation 1, because again there's no negatives, it makes life just a little bit easier. So writing out that formula again, I've got 3x plus 5y equals 13. So it's going to be 3 times 1 plus 5y equals 13. So that's 3 plus 5y equals 13. Take away 3 on both sides. So I've now got 5y equals 10. Then divide by 5. So I've got y equals 2. And then just reiterating outside, I've got x equals 1 and y equals 2. Okay, so in these ones, I only had to multiply one equation, but sometimes you're going to have to multiply both of them. So let's take a look here. So here I've got 4x plus 5y equals 7 and 7x minus 3y equals 24. So again, it's just easier looking at those middle numbers there. So I've got 5y and then minus 3y. And typically, it's just kind of easier to multiply each equation by the other number. So for example, the first equation going to multiply by 3 and the second equation going to multiply by that 5. So that's what we're going to do. So equation 1, we're going to multiply by that 3. And equation 2, we're going to multiply by the 5. So the first one, I've got 4x times 3, that's going to be 12x. 5y times 3 is 15y. And then 7 times 3 is 21. Then the next one, 7x times 5 is 35. And then 3 times 5, that's going to be minus 15y. And then 24 times 5, that's going to be 120. And then I've got to add them up. So 12x, and remember I'm adding them up because my signs are different here. So I'm going to add them. So 12x add 35 is going to give me 47x. The 15 ones are going to cancel out, and then my next one is going to be 141. And then I need to do this sort of division here. It's a bit of a nasty one. If you're ever uncertain on how to divide by 47, what you can always do is just repeatedly add 47 up until you hit that number. So that's one method that you could go about doing it in order to help out. So that'll be 1 carry 1. And so there we go. It goes, 47 goes in 1, 2, 3 times. So that means x equals 3. Alright, so now I've got that, I'm going to substitute that in. So I've got sub x equals 3 into, and I need to choose one of my equations. I'm going to choose equation 1. So I'm just going to write that out again, of 4x plus 5y equals 7. So that's going to be 4 times 3 plus 5y equals 7. So that's 12 plus 5y equals 7. Take away the 12 from both sides. So that's going to be 5y equals negative 5. And then divide by 5 on both sides. That gives me y equals negative 1. So just reiterating that, x equals 3, y equals negative 1. Okay, and the last question here. So again, I'm just sort of going to focus on the middle ones. So I've got that plus 2x and plus 5x. So I'm just going to multiply them both by their opposite one. So I'm going to multiply equation 1 by 5. And I'm going to multiply equation 2 by 2. Multiplying 1 by 5. And then multiplying 2 by 2. So 3y times 5, that is going to give me 15y. And then 2x times 5, that's going to give me 10x. Then 5 times 5 is 25. And then the next one, 2y times 2 is going to give me 4y. And I'll have that 10x equals 14. Look at my centers. My numbers are the same, but they're both positive, so I'm going to subtract them. And luckily, our things are lined up nicely that I can just do equation 3, take away equation 4, because equation 3 has larger numbers than its counterpart, so it means we're not going to deal with negatives. But you can always swap them around if you are going to hit negatives. So 15y, take away 4y, that's going to give me 11y. The x's are going to cancel out. 25 take away 14 is going to give me 11. Divide by 11, divide by 11, that means y equals 1. And then substituting that into our formula, we've got, so we're going to do sub y equals 1. I am going to choose just equation 1. Actually, no, let's do 2. Let's shake it up a little bit. So I've got 2y plus 5x equals 7. So it's going to be 2 times 1 plus 5x equals 7. So it's just going to be 2 plus 5x equals 7. Take away the 2 on both sides. I've now got 5x equals 5. And then I can divide by 5 to give me x equals 1. So y equals 1 and x equals 1. Let me know if there are any issues with this. It takes a little bit of time before you get your head around it, but then it's dead straightforward once you get over the whole multiplying the expressions. And yeah, good luck with the work.